Ladies and gentlemen, good morning. So, I'll start this morning being also, introducing the speakers, but also being the moderator of this first session. So, I ask Leonardo and Donato to join. So, the format for this morning, at least for this session, will be the following. I'll make a short introduction to the topic, then I'll pass the floor to our two esteemed speakers for 5-7 minutes each, so that you can introduce yourself and then present what you and your institution does. And then we will deep dive with some questions. Okay? So, and clearly, there will be at the end the possibility to open the floor for questions from the audience. So, to start with, allow me to try to put everything in context. And I would like to start mentioning the outer space treaty. Okay, yes, you may say that it was approved back in 1967, which is absolutely true. But in its Article 1, it says, and I quote, the exploration and use. Okay, good. Thank you. You know, technology is difficult. Okay. So, the exploration and use of outer space, including the moon and other celestial bodies, shall be carried out for the benefit and in the interests of all countries, irrespective of their degree of economic or scientific development, and shall be the province of all, the treaty says, mankind, allow me to say humankind. Now, it's true, the Outer Space Treaty entered into force on the 10th of October 1967, so we are getting to celebrate its 60th anniversary. And indeed, we collectively made it, or we may say that we are really embracing the spirit of the treaty. Why? The Committee on the Peaceful Uses of Outer Space, which started its activities in 1959, has above 100 members right now, is 102 or whatever, and keeps growing. We count currently more than 90 countries which have at least one satellite in orbit and counting. More and more government players are entering the scene, indeed, together with the rise of commercial activities and the space economy associated to all of this. The Outer Space Treaty, for therefore calling for a democratic access to space, irrespective of the degree of economic or scientific development of a country. And we see the rise of emerging and developing countries in the space arena. So, nothing to say. Point is, the more we collectively help new economies to grow, which is what we have to do, the more these additional countries enter into the geopolitical arena, and the more we do need a global agreement on the set of global governance rules which are mandatory to maintain the peaceful uses of outer space, and with it, peace on Earth. It's difficult to go against this. You may say, Monsieur la Police, but fine. New players from all over the world, public and private, are there. And so this is, in a way, the framework in which we should discuss about space junk and the situation, with the orbits contested and congested. But before I give the floor to you, I would like to mention something that is related to yesterday. There was just one reference made by Sarah at a certain point in time, and I would like to provide an out of the mainstream voice. Well, I do it quite often for your reflections. And is related to the current situation at EU level. So, the famous EU space label, which is the current approach that the EU is using, in my opinion, is a trick that the European Union is working on because they want to harmonize the member states' legislations without doing it. which, by the way, could also bring a lot of troubles to the European space industries in terms of competitiveness. The current approach, so the space label approach, may be considered not in line with the Article 189 of the Lisbon Treaty, which is the only article devoted to space, as you know well, which says whatever the EU is doing in terms of a European space policy or a European space program, it has to be done, and I quote, excluding any harmonization of the laws and regulations of the member states. Well, that's the treaty. The reason is that the European Union doesn't have the power to enter into the, let's say, the responsibilities of member states in this kind of stuff. So they had to go in this direction. So the European Union cannot harmonize laws and regulations. That's absolutely crystal clear. Okay. Having said that, the challenge for Europe and for member states, for the private and also for the private operators through their national authorities, needs to be in line. The problem is that they have to be in line with the treaties and the guidelines adopted by the UN, but at the same time they have to support the development of a sustainable space economy. Not a space economy per se, but sustainable. Okay? So, if this is the framework, and before we enter a little bit more in the debate, I would like to give the floor first to Donato Giorgi and then to Leonardo Barilaro, and ask you what you're doing yourself, your institution, and what do you believe should be the role of also this community, but we will deep dive a little bit more on the role of this community in the process, because as you know, all the stakeholders have to be heard. That's what I absolutely believe is mandatory in order to have an harmonious development also of the set of regulations that we need. So please, Donato.
Yes. Good morning, everybody. Well, what I do first today, I'm enjoying nice company, and I'm really happy to be here with you, as I was yesterday, by the way. But more in general, I am one of out of 10, less than 10, representative of CNES, the French Space Agency, around the world. We have between 8 and 10 offices in the major countries or regions where space has been developed or is being developed in a way that is important at international level. So we have an office in Washington, D.C. since the 60s. We have an office in Japan. We have an office in Bangalore. And I opened the office in Abu Dhabi in 2018, office that covers, let's say, the Middle East. Of course, today it's the UAE, the country that leads in terms of space exploration, Earth observation in the region, in terms not only of capacities, but development and not just in terms of capacity existing, but in terms of vision and will to build internal knowledge, know-how, and bring a real change to the society through the use of space as a catalyzer, let's say, for the change of the society. Before coming to the UAE, I was the head of the European International Relations CNES, and before that, with Simona, we saw each other in Brussels
younger.
and ESA, where we used to negotiate side by side, but sometimes head to head on many programs on space science and space exploration. I'll leave it here. Probably we'll talk about the content later.
Hello, everybody. Thank you, Simonetta and Andrea, for the invitation. And also can say yesterday I really enjoyed all the day. I'm Leonardo Barilaro, the space pianist. This means aerospace engineer and a pianist. And I will explain why I'm specifying this So I am a senior lecturer at MCAST in Malta, which is the Malta College for Arts, Science and Technologies. And I'm a senior lecturer in aerospace engineering and aviation, and I follow the research in both fields. Malta, in terms of aerospace, is a very young country because of the first agreements with ESA date back to 2014, so just 10 years ago. And now, only in the very last few years, is opening up to bigger projects, also related to space debris, and more to the international community, with the target of improving its status in the framework of the PEX agreement, so the Plan for European Cooperating States. And in this framework, it is a very good opportunity, talking about also the research that I do, to level up step by step, and also looking for collaborations. We are collaborating with University of Padova in Italy, the university from where I come from, Southeast Technological University in Dublin, plus other collaboration here and there. And very recently we started a collaboration with Professor Andrea Macciò on ASTROBEAT, the main project I'm following now, so opening also a bridge with NYU, basically. Pianist, so as a pianist, I carry on an activity of dissemination and public outreach, connecting the music to the space activities. And with previous Maltese mission and the new one that is upcoming on board of the International Space Station, the music was sent to space and symbolically was streamed back to Earth. Now, why to do this? One of the reasons is that in a country like Malta, and not only Malta, the space field is very little known. So to reach to a wide public, instead of leading of, this is a bioscience experiment, or this is an experiment to test new technology related to space debris, also on the public news outlets is much easier to arrive first with something that attracts attention, as it is, and later it is an opportunity also to interest young students and also maybe engineers that are finishing their bachelor, maybe want to switch to aerospace. So there are a lot of ramifications, and this is in a nutshell what I do.
Okay, thank you so much. And now allow me to ask you a question, in particular to Donato first. So we mentioned that we need global governance, space traffic coordination. This is because the number of satellites is increasing and the number of debris is increasing, obviously, due to the fact that there are more players in the space arena, and not necessarily, at least at the very beginning, everyone was following the space debris mitigation guidelines and all the long-term sustainability guidelines. Now, so at the same time, we have the duty to maintain a democratic access to space for all the players who want to use it for peaceful purposes. So, in your opinion, how we should take into consideration, or I mean, there are ways to take into consideration which kind of process we should follow in order to take into consideration all the needs of all the stakeholders, and in particular, the needs of the scientific community and the civil society and the astronomers.
Thanks, Simona. It's the question is a little bit tricky, but I think because it's with the state of multilateral role today, the multilateral negotiation today is frankly speaking quite beautiful. We have a situation where part of the countries, some countries are sanctioned for their actions. There's a new global order that is setting up. So it's very difficult today to imagine an order and a process that could be new and more efficient of the current one. But I think that talking about debris today is very appropriate for globally talking about dark and quiet skies. And why? The topic of dark and quiet skies is in reality a little bit quite recent. We heard yesterday, it was Patricia Cooper, I think, I don't know exactly her name. She said February or March 2019, first launch of a set of Starlink satellites, and the problem started to come, to be very clear. Astronomers, for example, will not be able, if we go ahead like this, astronomers will not be able to work from Earth anymore. But the problem of debris is a much older problem. It's a problem that has been somehow dealt with. No, it has been dealt with the tools that were available in a period where multilateralism was already a bit shaken. Not as shaken as today, but it showed that in some way, even between countries that don't talk to each other officially, but they do it in a very discreet, unofficial way, you can get to results that are, for example, the guidelines that were approved by COPOS in 2009. So thinking about a method today, it's again very complicated because of the current situation of international affairs. But we have an example that is the one of space debris that shows that people can talk without going first to the political level, but more on a technical level. The first discussions about how to regulate debris started between agencies with an entity called IADC. And my engineers with mustache and pants here and shirts with, it's an image, a very French image, l'ingénieur moustache. People were very good technically, and they're the real good geek that we all enjoy working with because they're competent, they're good, and they're nice people. So these people started to talk to each other. The French talked to the Russians talked to the Chinese talked to the Australian, etc., etc. And eventually there was a set of rules that were considered the best we could have in terms of effectiveness and democratic approach. Why? Because if you want to reduce debris, the first thing you have to do is to avoid proliferation. And why do you have, and how do you avoid proliferation? Is to apply some measures to your launchers, to your satellites, in order for them not to remain in orbit forever, in order for them not to explode in orbit. We have everything. We have explosions of upper stages of launchers. We still have upper stages of launchers and satellites that are not active, that are still in orbit, and it might stay for hundreds of years. So the decision about a set of rules that was made first, just purely technical. Let's listen to the competent people, those who every day build satellites or build launchers or do the launch of these engines. Listen to them from any part of the world, and try to build something that is feasible for everyone. Because some point a few years ago, I heard political representative quite important in the region at that time saying, we're newcomers, we should have easier rules. I'm sorry, but it's not because you're newcomers that you're allowed to build cars with 3 wheels or cars without the seatbelts. There are minimum rules that have to be the same for everybody. And of course, these rules must be loose enough to allow everybody to access space, and as well to not impact competitiveness, which is a problem. At the beginning, industry was absolutely against having these kind of rules put in place at national level because it has an impact on competitiveness. But eventually, it became so necessary to clear out orbits and avoid potential problems in the future, that even industry worldwide realized that it was essential eventually to improve their competitiveness in the future.
Yeah, thank you so much. Also, because on top of that, I would like to mention also something that I wanted to mention already yesterday, but there is someone also at a top level mentioning from time to time that we should limit the number of satellites that, for example, each country could launch. Well, we are not limiting the production of cars. We are not limiting the production of planes. So why we should limit the production of satellites? Just a question. Huh? It's and if we want to go ahead with the real democratic approach, so that each country, independently from its economic and social development, is able to access space, we have only 90 countries, only quote and unquote, a little bit more than 90 countries having had at least one satellite in orbit. The number of member states part of the UN is 193, so we're not yet even at 50%. And yes, you can question why Rwanda is filing with ITU a constellation of more than 300,000 satellites. Well, it's indeed the question mark. But there are a lot of question marks we have to deal with. Still, I believe that the democratic approach to space, the democratic access to space, must really be maintained, because that's the only way to allow everyone to be on the same page. As the 2030 agenda says, we don't want to leave anyone behind. Please.
What about the danger of building a monopoly in space, a monopolium?
Well, this is true also in other fields.
Yes, but there are laws trying to dump this possibility on Earth. The European Union, for instance, is discussing with big software and hardware providers in order to improve competitivity or whatever, to allow more industries in the field, while in space we see that something strange is happening. One single person owns much more than half of the satellite in orbit.
Correct.
So it's a strange situation.
If I may, you can own as many satellites as you want, but the problem is not the number of satellites. The problem is the resources available. If it was the only person, one person owning on the the telecom, where there are all the satellites, geostationary, sorry, basics, on the geostationary orbit, one person owned all the satellites or 90% of the satellites, that would be a problem. That would be a real monopolistic problem. And at that point, I think there would be on Earth, governments say, no, that's not acceptable. We're in a transitional phase now. It's a very new phase. And it's right. One person owns, what, 80% of satellites? But there's still room for many more of these satellites. And by the way, there are constellations that are foreseen on Rwanda, 300,000 satellites, etc.
320 to be precise, but okay.
But I believe that how the world works, at some point, maybe when it will be already a little bit late, there will be countries say, no, it doesn't work. But at advantage of these satellites is that they fall.
Yeah, but there is also another, again, for debate, on the general position of the European Union of trying to put taxes and limit, etc. There are a lot of articles and even books now that are focusing on the fact that this is creating a situation, a sort of a, let's say, when you are stuck in a situation because you want to over-regulate, which is potentially from one standpoint correct, but at the same time is blocking your industries, and the competitiveness of Europe is going down. So the problem of Europe right now is that probably on one side it's correct, the approach, because why these big companies, internet companies, should have the monopoly of this and that and should not pay taxes at the level that others pay taxes. But at the same time, the effect of that, the drawback, is that Europe is stuck. Now, there is an interesting book that I read recently where there is an example, and again, I'm not commenting, I'm just reporting the point. It seems at a certain point in time, the antitrust in the United States started with, and the ones who are coming from the United States, you can confirm that or not, because the book has been written by a famous CEO in Italy, so it may well be that all the the information I'm not precise. But in any case, the point is that IBM had a quite a strong position with respect to hardware development, right? So was clearly a big player in the world. And so, and this is seen from the American standpoint. So it was quite an important player. Then they started to work more and more on the software side. And then the American antitrust decided that was really against, the opening of competition in the market. And the actions that they took, I mean, according to this individual, brought IBM to the situation in which it is right now. So, in a way, in the hands of the Chinese. Now, it is something that the government has to deal with in a way that then it is creating troubles to its own companies and the possibility for these companies to be competitive on the global market. It's a question mark. I don't have the answer. It's just, to help the debate. Please.
So my approach is more on the technical side, and I agree 100% with what was said. And also, I believe that the analogy with the automotive industry is very interesting. So I have a more pragmatic approach, also because I don't have too many expectations about full measures that are fully applied at international level, and I believe that in reality can be slowed down the process, but satellites will increase like cars. So for cars, they are increasing still nowadays. The one approach was to make them safer. Regarding space debris, basing the considerations on physics and on what is available, I see the so-called mitigation approach as a more feasible way to mitigate this risk, in the sense that improving, so there is a lot of talk, for example, about active space debris, which is a solution, but is super expensive with a lot of limitations and additional risks, because imagine if an active debris removal mission fails, is simply more junk up there. And also the monitoring improved in the years, but is still practically not feasible at a certain scale. So I would focus my attention on the smaller debris from which basically spacecraft can get protection till a certain extent. To get smaller debris, despite the increase on spacecraft and so on, what can be done can be improved the shield design improving their fragmentation. So is since what was 1947, the concept of Whipple shields brought at a higher and a higher level. So improving the shields and also studying repairing techniques. So now more space stations are on the way to be in orbit, more and more missions, and plus the plans for humans on the Moon and Mars. So another way to limit the amount of junk is in developing space debris repairing methods. So in my opinion, these are two very pragmatic approaches that also has less to do with politics. And I agree perfectly with his analysis. It's just something that most of countries could agree on. So and in the same way, also in setting a minimum requirements also for newcomers, in saying, okay, put the airbags in your cars, and 30 years ago was not mandatory. So this is my point of view.
I absolutely agree. And before I give the floor to Federico, I would like to mention something that may be again helpful for discussion. When we talk about active debris removal, the issue is not, unfortunately, is also highly political. And the reason is that when you acquire the technology to go in space and being able to grasp a non cooperative object and bring it down, so if you reach this level of technology, you can do it with, for commercial purposes. So you have a customer, a client that is paying you for doing that. But in principle, when you have the technology, you could do it even with a non, let's say, friend satellite. So with the satellite, this can become a weapon. As I always say, I mean, if you drive a car, it's not a weapon. The car is not a weapon. But if you use the car to kill someone on purpose, then it's a weapon. The same concept there. So you have a satellite which in principle has been developed to clean up a little bit, so which means that is a noble scope, and then you use it for other reasons. This happens every time we develop a new technology in every field, so it's not something new. But it's an element that is bringing member states in the UN being very cautious in approving long-term sustainability guidelines related to active debris removal. So just to give a little bit of political context, Federico.
That's very, very interesting. My question was not going to ADR. I agree with you on difficulties on that. I was just surprised on what you mentioned, Leonardo, about your approach on shielding of satellites. And that makes total sense for me as an engineer. But I never heard that before. So I always hear about cleaning space, right? Trying to clean it, clean it, clean it. And then what you just said about shielding the satellite sounds more like making the car robust. So if something happens on the road, your car doesn't just break down because of it. Do you think that the space industry is also looking into that? Because if you have to make the satellite more sturdy, it will be heavier, it will be costlier, and so on.
So first of all, thank you for highlighting the point. Second is not exactly more robust or sturdier, but better in breaking down. in the sense, in the sense that basically the key factor in shielding is the amount of kinetic energy impacting the shield. So we can't operate on that because there are the debris and that is related to mass and velocity. When there is an impact, if you are able in the first layer or in the first part of the shield to fragment enough a debris, yes, you will have still problems of orientation and so on. But with creating a small debris, they are much less threatening for other, first of all, for other satellites, for example, and also you are able to preserve more the real payload. So, for example, electronic, scientific instruments for measurements. So the approach is so I believe we can't really tell people stop sending satellites, and the number will increase. Everyone, I guess, heard at least once the so-called Kessler syndrome, which is a real threat. Considering that we will not stop doing new launches, what we can really do on a practical level is improving the shielding. So yes, you can do improve also their performances, improving their size weight ratio. You can improve how they get destroyed. So if they create small fragments, it's much better than a big shield, very sturdy, that creates for big debris that are very threatening for other missions. And also I was mentioning the repairing techniques because, for example, one project I'm following is about 3D printing of shields in composite materials, so basically Kevlar and carbon fiber. So the idea is on the long term, there is a damage. You are on a space station like one over one along the way, like Halo by Vasta, and there are many of them. You are on orbit, you can 3D print your repairing patch on the spot, let's say, to repair the above all if it is a manned module. So that is an improvement instead of having a big chunk of debris simply left to float. And the other is another project, is very experimental because till now, at least to my knowledge, no one tried, is to use on purpose called the welding adhesion, which is the ASTROBEAT project, which also with Andrea we started the collaboration. So to use called welding adhesion to apply a patch, of a bit of a concept of a rivet in aeronautic, to repair a localized damage using cold welding adhesion. So basically everything is based on the use of contact forces. So this is at least one of the possible reply that has a pragmatic approach that also by international, at a high level, international committees can be measured. So let's say we deploy a constellation of, how much was around 3,000 satellites?
320,000 satellites, the one filed by one.
Okay, let's say they go really for that. If they can prove that they have a new generation of satellites, also in terms of shielding, that probably by an international community can be better accepted in a pragmatic way. I'm an engineer, so when you can measure things, I think is much more reliable what you can offer. And I believe this is doable at the current state of the art. I don't know if you want to add something.
No.
Okay.
Oh, just one point. One of the things is that the commercial sector, so the private operators, have an interest, a vested interest in trying to mitigate the number of debris and the impact of debris, and also to try to clean up outer space. Why? Because clearly, every time they had to perform a collision avoidance maneuver and things like that, it's costly. It's not, for free. So the more you are an operator that has a big constellation in orbit, the more this has an associated cost. So the more the low Earth orbit is clean, the better it is for private operators. So believe it or not, we have to rely on the commercial sector to try to push them, that they push member states to find an agreement on a new set of rules. The sooner the better. So we have 1 minute. Federico.
Thank you. So related to debris, I was looking at the ESA debris report, something like that. It was issued in this year, I think, or last year. And there was a graph that said cumulative number of collisions if we don't do anything or something like that. It looked very scary.
Yeah.
And it went like more than 100 collisions by 2100 years, right? So in 80 years. So do you think that the situation of debris is only going to get worse? Or do you think that there is a way of at least keeping it steady, or will we always have to think that space is only will get worse somehow, or very worse or a little worse?
So from a technical point of view, and we don't take into account possible mass extinction events in case of a very big debris hitting our planet, I think that as how are things now is exactly like cars or aviation. So the number will increase. What will improve is the protection. It's a bit also like computers. The number of viruses to get advantages in infecting a system simply increases. What became better is how we protect our systems. So in terms of numbers, will increase. If there will be major fragmentation events, could be that yes, there will be a partial, at least, collapse of the full infrastructure, at least in low Earth orbit. This is a possibility. If I mean, of course, I can't know, but in the short term, so let's say 10, 15 years, I only see an increase of that with an improving of what we have available, and also in the probably exploration of also other orbits for more commercial uses, even though now the, of course, is mainly in a LEO everything.
Well, with my crystal ball, I would say that at some point, as Leonardo said, the problem will keep increasing. At some point, collisions will become very frequent. At that point, the commercial sector will complain with states, say, why didn't you do anything to avoid this? And then we will have international regulations
Done.
somehow done, and then there'll be stabilization, like for everything. Because regulation is not always negative.
No, absolutely.
Simonetta.
I know well. Last point before I close, which may be helpful again for future elaborations. Even when you are very good in following all the rules, like the European Space Agency does, it's one of the best, to be honest. Still, you may encounter some troubles in your life, and one above all is envisage. So they made a mistake in calculating the amount of fuel on board. They asked member states to extend the scientific mission, which was good. But at the moment in which they had to make the control re-entry, they realized that the amount of fuel was not enough. And now it's tumbling. It's a big beast tumbling in orbit. So even when you are very good, you can make mistakes. Everybody. So thank you so much. And now I give the floor to Professor Macciò so that you can continue.